Hi, I'm going to redo the first part of the lecture because I had some errors in the angles, and I also wanted a chance to re-explain some of the creating the unit circle because it's so important. So here we have the unit circle. How do we fill it in? Well, the first thing is that we want to start off with the angles. All the way around, and we always start from the right side here, all the way around counterclockwise, is an actual distance of 2 pi. If we have time, which I hope we do, I want to do some of these measurements with you in class experimentally so you can really see that the distance around a unit circle is 2 pi. Now, when I mean distance around, that's the length of this string which is made into a circle. When we say unit circle, what we mean is that if I started at the center and went a distance out to the edge, that distance would be 1. That's what we mean by unit circle. If all the way around, starting from here and going all the way around is 2 pi, then halfway around would be half of 2 pi, which is pi. If I start from here and go halfway around the semicircle, well, I'm half of pi, which is pi over 2. I can get the angle directly across by using the method I showed you in class, that if I take the numerator and denominator and add them, I will get the numerator of the angle that's directly across. This angle here turns out to be right between 0 and pi over 2. So half of that angle is pi over 4. These two angles are probably the hardest to get. I know one of them's pi over 6, I know the other one's pi over 3. How do I know which one goes first? Well, pi over 6 is a smaller number than pi over 3. And if you have trouble understanding this with fractions, you can just take pi and divide it by 6 on your calculator and figure out if it's smaller than pi over 3. The smaller number has to come first, so that's pi over 6. I've got an angle of pi over 6. And then the next number up must be pi over 3. Now, notice I put this 5 pi over 4 across. I can get that by adding the numerator and denominator method. And I can also get the other angles, which I had incorrect. I had added numbers and got a 5 here. It's really 7 pi over 6 and 4 pi over 3. Now, this angle over here turns out to be the same amount as this angle over here. This angle here is pi over 4. So to get this angle over here, I need to add pi over 4 to pi over 2, which turns to be 3 pi over 4. Another way you can think of this is if I go all the way around to pi, this angle right here is 3/4 of the way towards my goal of pi. So it's 3/4 of pi. That gives me that angle. How do I get this circled angle? Well, the circled angle from pi over 2 is the same pizza slice as right over here, which turned out to be pi over 6. So to get this circled angle, I will take pi over 2 and add pi over 6, which turns out to be 2 pi over 3. This gray shaded area right here is the same as this gray shaded area. This gray shaded area is the angle for pi over 3. So to get this circled angle, I would take pi over 3, but I'm not starting at 0, I'm starting at pi over 2, so I need to add pi over 3 to pi over 2, and I'll get 5 pi over 6. And there you have it. Now, by using the method of every angle across is going to be the numerator plus the denominator on the new numerator, I get all the angles in the entire circle and have all the angles in place. Done. So what is cosine t and sine t? Well, by definition, cosine t is the x-coordinate of any point on the unit circle. So for example, cosine of pi over 2 would be the x-coordinate at pi over 2, the actual x value on the coordinate system. Likewise, sine of t turns out to be the y-coordinate of the point on the unit circle. So I can fill in some of these fairly easily. The x-coordinate over here is, well, the radius is 1, so I've gone a distance of 1 across to the right, so the x value is 1, and the elevator has not gone either up or down, so the y value, which is the movement up or down, is 0. Over here, on the other hand, the x-coordinate is 0 and the y-coordinate is 1. Because the x-coordinate hasn't gone left or right, and the y-coordinate has gone up a height of 1. Over here, on the other hand, the x-coordinate is -1 because I've gone to the left -1, and the y-coordinate is 0 because the elevator has not gone up or down. And down at the bottom, the x-coordinate is 0 because I haven't gone left or right, but the elevator has gone down 1. So the y-coordinate is -1. The y-coordinate is always the amount you've gone up or down, and the x-coordinate is the amount you've gone left or right. So here's how you get the sine and cosine of at least the values I filled in. The cosine's always the x-coordinate, and the sine is always the y. So the 0 that you see here in white is the cosine at pi over 2, and the y value, 1, is the sine at pi over 2. Likewise, if I go over here, cosine at 0 is 1, because that's the x-coordinate there, and sine at 0 is 0. Now, I never remembered these initially, that here at pi over 4, I have square root of 2 over 2, square root of 2 over 2. One thing I did remember, though, is at y equals x, that's the line that cuts the diagonal, the y-coordinate must equal the x-coordinate here, right at the diagonal. It's halfway. And you might forget, maybe it's square root of 3 over 2. One of the things you could do is just plug in cosine pi over 4 onto your calculator, and you'll get a number around 0.7. And either you can remember that that number is square root of 2 over 2, or you can just punch square root of 2 over 2 into your calculator and check that they're the same thing. It's got to be either 1/2 square root of 2 over 2 or square root of 3 over 2. So you can play around and numerically experiment till you get it correct. Now, these two coordinates are flip-flops of each other. How do you figure out which one's which? Well, here's the way I used to do it. Square root of 3 over 2 is around 0.8, and 1/2 is 0.5. Now, if I go on the x-coordinate here, I've gone farther across than I have gone up. So the distance across the x-coordinate is larger than the distance up, the y-coordinate. That tells me that 0.8 comes first and 1/2, 0.5 comes second. 0.5 is the amount the elevator goes up, 0.8 is the amount the elevator goes to the side. So that tells me that square root of 3 over 2 must come first and 1/2 must come second. Once I have that, I'm done, because the pi over 3, they're flipped the other direction. What about the values in that pink region? Now, how do I fill those out? Well, it's pretty easy. I can fill it out pretty fast now. First of all, the y-coordinates, that's how far the elevator goes up, is going to be exactly the same as the y-coordinates I just filled in. So right here, I have a 1/2. So right here, I'm going to have a 1/2 as well. The only difference is, instead of going to the right on the x-axis, I'm going to the left. So instead of having square root of 3 over 2, I'll have negative square root of 3 over 2. Instead of having square root of 2 over 2, square root of 2 over 2, I'll have negative square root of 2 over 2, square root of 2 over 2. And that's because the x-coordinates here are negative, because everything here is to the left of the x equals 0 point. Up here, it's going to be a flip-flop of the numerical values with the negative on the first coordinate. What about this region? Well, this region also you can get from all the other ones. From here to here, they're the same. The x-coordinates are the same. I've gone the same amount across. So I get, and it's still negative. I'm going to the left. But the y-coordinates are actually negatives of each other. And this is still messed up here. This should be 1/2, negative 1/2, and negative square root of 3 over 2. And I'm not going to correct that because I just spent a little while correcting that. It's corrected here though. So you see that over here I have negative 1/2, which used to be positive 1/2. And that's because I dropped down here from positive 1/2 to directly below it, which is negative 1/2. The values here are both negative because I'm going left and down to get to these points. What about in this green region here? Well, those are also easy to fill. Again, I use the same logic. Here I have a half to go up. I'm going the same distance but down. I get negative a half. And so I'm able to fill in all the points. What am I able to do with this once I have it filled in? With sine of 2 pi over 3, I would go to the angle 2 pi over 3 and check out the y value. And it turns out that the y value at 2 pi over 3 is square root of 3 over 2. What about cosine at 5 pi over 4? Well, I just look at the x value at 5 pi over 4, which I've highlighted here, and I get minus square root of 2 over 2. So the answer is minus square root of 2 over 2. And so that's how we use the unit circle, and this is how we create the unit circle. And it seems hard because I drew it out very carefully and slowly to explain it. But when you do this by yourself and you do it a couple times, you'll be able to create the circle really quickly, and it provides a lot of knowledge on how cosines and sines work and where they belong and what they mean. You'll have a full understanding, and no one can turn you around and ask you any weird question that you can't answer. So it's really important to get this correct.